All right, it's time to talk about mole ratios and mole conversions. Some things to remember. So you should already know this. We use subscripts to count atoms in a formula, like this. Okay, so this 4 means there's 4 oxygen. This really has a 1, so 1 sulfur. This 2 means there's 2 sodium. When there is a 2 outside, or a different number outside of parentheses, that number outside the parentheses applies to both things inside the parentheses. Okay. When using moles for formulas, subscripts also refer to mole ratios for the elements in the formula. So what do I mean? Well, if I have 1 molecule of CO2, that means I have 1 atom of C and 2 atoms of O that are bonded together. But if I have a mole of CO2, that means I have a mole of carbon atoms and 2 moles of oxygen atoms. We can use subscripts to determine mole ratios in a formula. What do I mean? Well, what is the mole ratio of sulfur to hydrogen? Well, in this formula, sulfur does not have a coefficient, so it would be a 1. Hydrogen does have a coefficient, it is 2. So the mole ratio is 1 to 2. We can write it like this as a ratio, or like this, or like this. All correct answers. What is the mole ratio of oxygen to nitrogen? Well, oxygen has a subscript and nitrogen has a subscript. So I write it as 4 to 2. But that's not right. We have to reduce it. Ratios have to be reduced. So divide both of those numbers by 2, and we get 2 to 1. In balanced equations, coefficients need to be in the smallest whole number ratio. So is this equation balanced correctly? Well, yes. The same number of atoms of each element on both sides. What is the coefficient ratio? So I just go look at the coefficient in front of each thing. 1, 2, 1, 2. Like that. Can I reduce those coefficients? No, I have a 1. If you have a 1, it's guaranteed to be the smallest whole number ratio. So no, I can't reduce them, so it's balanced correctly. All right, let's look at this equation. And if I balance it like this, the ratio for this one is 4 to 2 to 4. That is not the simplest ratio. Divide each coefficient by 2, 2 to 1 to 2. So correctly balanced, it would be this. Remember, if it stresses you out to leave a blank, you can write a 1. Is this equation balanced correctly? Well, yes. What is the coefficient ratio? 2 to 3 to 4 to 3. And the only thing I could divide those all by is 1. So they can't reduce anymore. Is this equation balanced correctly? Here's one where I started the balancing process by putting a 2 in front of the thing that's being burned in a combustion reaction. No, I have to reduce the coefficients. So what is the coefficient ratio? 2 to 10 to 8 to 6. So I can divide them all by 2. So I get 1, 5, 4, 3. That's the correctly balanced equation. In balanced equations, the coefficients determine mole ratios. What do I mean? Well, this coefficient of 2 means there's 2 moles of hydrogen molecules for every, this has a 1, for every 1 mole of oxygen molecules. Using the equation, so here is my equation right here. What is the ratio of N2 to H2? Well, N2 has a 1 and H2 has a 3, so 1 to 3. For N2, to NH3. 1 to 2. And H2 to NH3. 3 to 2. Okay, so you start with the one that is listed first and you just check coefficients. That's it. Okay, what are some mole ratios from this equation? So if I want C3H8 to O2, O2 to CO2, CO2 to H2O. So you can see it just matters. Just look at the coefficients. You do have to make sure that the equation is correctly balanced first. C3H8 to CO2, C3H8 to H2O, and O2 to H2O. Now you can see none of these need to be reduced because I have a 1 here. I know it doesn't need to be reduced. Here I have odd numbers, odd with an even. I know I can't reduce that. This can't be reduced by anything by 1, except for 1. The substance you run out of is called the limiting reactant. And why? Because literally it limits the amount of product that can be produced. So what do I mean? Well, if I have this much H2 and this much O2, I can make this much H2O, and then I have some leftover O2 that I don't need. So the amount of product is determined by the limiting reactant. The other reactant is called excess, meaning I have extra. So in this case, I have this many hot dogs and this many buns. Here's how many hot dogs I can put in a bun. Notice I have a leftover hot dog. So what was the limiting reactant? What limited how many hot dogs I could put in the buns? The buns. Once I ran out of buns, I couldn't make another pair. All right, so when I determine limiting reactant, how many sandwiches can I make? So each sandwich needs 2 slices of bread, 3 pieces of lunch meat, and 1 slice of cheese. So if I have 6 slices of bread, I could make 3 sandwiches. If I have 12 pieces of lunch meat, I could make 4 sandwiches. And if I have 5 slices of cheese, I could make 5 sandwiches. But first of all, that number's not all the same. So that means one of them is limiting it. So the 3 sandwiches I can make from the bread is going to limit how many sandwiches I can make. I'm going to have extra lunch meat and extra cheese, but I still can't make another sandwich. So what was the limiting reactant in this case? What did I run out of? The hydrogen was in excess. The oxygen was the limiting reactant. What was the limiting reactant in this case? What did I run out of? I also like the way that this is written. I started with 3 moles of N2, 6 moles of H2. Afterward, you see I still have 1 mole of N2, so that means I ran out of H2. Which was the limiting reactant here? I2. Okay, we can also do some calculations using mole ratios. Let me show you what I mean. Okay, so here's a balanced equation, and the question says, suppose I had 20 moles of H2 and plenty of O2. So what that means is this is the limiting reactant because I have plenty or extra of this. How many moles of H2O could I make? So start by what you're given and put it over 1. Okay, now I don't want moles of H2, I want moles of H2O. So I need to convert between H2 to H2O. I use mole ratios to do it. So I know I have to get rid of moles of H2 and I want moles of H2O. Now, how do I get this mole ratio? Go back to the balanced equation and write the coefficients. All right, so that allows me to cancel that out. And this is 20 times 2, which is 40, and then divided by 2, which is 20. So there we go. What about if I had 10 moles of O2 and lots of H2? So how much H2O could I make? So start by with what you're given. Okay, and I know I need to cross out moles of H2O, convert it to moles of H2O. How do I convert from moles of one thing to moles of another? Use the mole ratio from the coefficients. It has to be a balanced equation though. So put those coefficients, those cancel out. So that's 10 times 2, which is 20, divided by 1, 20. Different equation. If 10 moles of NH3 were produced, how many moles of N2 would be required? So write what you're given, put it over 1. You know that you need to cancel those out. What am I going from NH3 to N2? Look at the balanced equation, write the coefficients. 10 times 1 is 10, divided by 2 is 5. Voila. Okay, let's try this one. Write what you're given. I know I need to cancel out moles of H2. I want to convert to moles of NH3. Grab the subscripts from the balanced equation. I know that allows that to cancel out. So 3.3 times 2 is 6.6, divided by 3 is 2.2. What if I get this number of moles produced? How many moles of H2 are required? So write what you're given, put it over 1. I know I need to cancel out moles of NH3, convert it to moles of H2, get those subscripts from the balanced equation, cross out that, you're left with moles of H2. So I do 0.600 times 3, and then divide that by 2, and I get this. Now you are going to practice. That's the only way to get good at this. Practice on your own. And there you have it. That's mole ratios and mole conversions. I hope you learned something new today.